The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to this webinar. My name is Michael Evangelista and I will be your moderator for today. Just a few reminders that you are in listen-only mode to avoid unnecessary background noise. However, you can type in your questions anytime you want in the question box, and those questions will be answered by our panelists in a Q&A segment. The recording and certificate of this webinar will be sent out in 2 days' time, and our topic for today is about the automated overcurrent relay testing, which was presented by our colleagues from the Middle East, Murtada Abu Al-Rahi. So without any further ado, let's start this webinar. Great.
Hello everyone, thank you for joining us today. Welcome to Megger's monthly webinar series. Today's topic will be on automated overcurrent relay testing by Megger RTMS software. You can submit questions at any time during the presentation by typing in the box, and I will read the questions out during the Q&A segment at the end of the webinar. Remember, you can ask questions at any time during the presentation and they will be answered at the end of the webinar during the Q&A session. Our presenter today is Murtada Abu Rahi, and afterwards Ali Hussein will be conducting a practical session as well via webcam. Okay, let's go ahead and get started. Thank you for joining us today, Murtada.
Assalamu alaikum. Good day for everybody and thank you for attending our webinar today. We hope everybody is safe and far away from the virus, and just keep yourself safe and your family. Today we are going to talk about the Megger approach in testing the overcurrent relay via the RTMS software provided with Frege and smart equipment. So today we will talk about briefly about some only general idea about the introduction about protection and what is the overcurrent relay and why we are using it, then the types of the overcurrent relay, how to test those overcurrent relay, and then automated testing by Megger software. A lot of questions everywhere and everybody is asking. Even when you go to a guy who's working in power system, maybe in, let's say, start a new fresh engineer, you ask why we have the protection. Why do we need the protection? So a lot of people ask this question. Do I have to have protection? Do I have to have overcurrent relay? Do I have to have transformer differential while the overcurrent relay can cover that? A lot of questions come. So the question comes, is it important to have this protection relay? Why should I have the overcurrent and not having, for example, thermal relay? Do I have to have the distance relay or only directional overcurrent relay? So a lot of questions comes there. And then that question, do I have to have also a coordination between them? Meaning that do I have to do the calculation and say why my feeder should trip before my incomer? Let them trip together, for example. What is going to happen? These questions are facing in the field, especially in the utilities and some factories, that they don't have much experience with the protection. So a lot of question comes. One of them is, why do I have to use this type of relay, not the other type, or this manufacturer? Why shall I go to that country, not this country? So this is also something for the relay, you know. So we have a lot of different relays in the market. So which one is good? Which one to choose? A lot of questions. And to answer those, of course, we shall have the protection relay correct that. And if we misuse it or done something wrong, we'll end up with having something like this. Poor protection relay scheme, failure of relays, not correct coordination, different type of relays will result in disaster, will result in a total blackout. For small amount of money, people will lose millions if they choose something not related to the correct scheme or correct, let's say, coordination or correct relay to be used. Pictures are speaking about the protection and the importance of the protection relays. So because of that, we know now it is very important to have the protection, and we should have the right protection relay for the right equipment. And the objective is to keep our power system stable by isolating only the component that under the fault, meaning that when I have a fault in a feeder, I should trip only the feeder. We should not trip the incomer. When I have a fault in transformer, I should trip the transformer, not the generator. And that's to keep the power system. Those devices which are doing this job and doing all the calculation and making the power stable are called protective relays. Those relays, one of them is the overcurrent, which is our subject for today. So the main purpose of those is to do to isolate the faulty portion and keep the healthy portion available. And this is the main idea behind the power protection relays. So why it's overcurrent relay? Why I'm talking about the overcurrent relay? Overcurrent relay basically is used from generator till even the distribution side. So wherever you go, from generator, you have an overcurrent relay. When you go to a transformer, you have an overcurrent relay. When you go to transmission, there's an overcurrent relay. When you go to distribution, there is an overcurrent relay. Even in our houses, there is an overcurrent relay. So we have different types of overcurrent relay everywhere. That's why it's the most common relay used in the power system is the overcurrent. And based on the overcurrent theory, the other relays are working. So sometimes you see distance relay by supervised by overcurrent relay. Sometimes you see transformer differential, the operating coil is overcurrent relay. So it's always overcurrent everywhere. So the overcurrent relay protection is defined as a relay which operates when only the value exceeds its setting value, meaning that whenever I have a value set like 1 amp and it exceeds, this will execute an output. And then the output will look for another logic, which is the timing, which we will talk about now. The overcurrent relay can give us a protection against most of the short circuit and overloads. So it's air faults, phase faults, etc. Everything is going to be covered by the overcurrent relay. So how many types we have? We have mostly common type is the instantaneous overcurrent relay, which is used mostly whenever we have short circuit, severe short circuit that will have more than 8 to 10 times short circuit current. And the tripping time will be like 100 milliseconds or below. And then we have defined time or definite time overcurrent relay, where we will trip after some time to allow something like for backup protection, and sometime also to do something like coordination. And then we have the inverse time overcurrent relays, which will operate in a different way, like when the current goes high, the time will go low, and it's, let's say, it's a different way of doing coordination. Again, it's been designed for the coordination. So whenever the fault current goes high, the trip time will go very short. We have most common of this is the inverse, the inverse, and extremely inverse. And the last one in the family is the directional overcurrent relay. And here we have another thing here is that the direction of the current we have to determine to give the trip. We have to look either forward or reverse. So our overcurrent relay have to be polarized to understand the direction of the current flow. Now, about the definite or defined overcurrent relay, it's, as I said, it operates instantaneously. So whenever the current meets the set value, it's going to trip without any time delay. This is typical for outgoing feeder, as it's written here. Typical for, as I said, even for we have it for in the generator also we have it. We have it so many places. Now, the defined overcurrent or definite time overcurrent, it's a backup protection, as I said. So when the current exceeds the value, it waits for another timer to give the output. So the logic here will have another timer to give me an output after set time, and this is to allow the coordination for a backup protection. And then we have the IGMT relays or time overcurrent relay, which is inverse, very inverse, extremely inverse. And this is, as I said before, the higher current will operate in a very low time. So it's a really big area to do, and the definition is that we have to choose the right relay for the right purpose. This is something about the curve that we are using here for the overcurrent. This is only a sample of different time, very inverse and inverse. So whenever the current goes high, as I said, the tripping time goes low. Then the directional overcurrent relay, as I said, it has to be controlled by something, and this is going to be controlled by the voltage to determine the direction. This is very important when we are doing the, for example, the transformer. So we have to have a directional overcurrent relay for the transformer. So it looks at the transformer faults. It's not looking at the the generator side, for example, faults. Or if it is a feeder, then it has to look at the feeder, not the bus bar, if there is a bus bar fault. So directional overcurrent also is very, very important, especially when we have parallel line, to understand the situation. So it is like selectivity. If we have it selected, we'll have a direction. It means that when I have two parallel lines, and then if they are not, let's say if they are normal overcurrent in another direction, if I have a fault, it may do an open end, while if this direction overcurrent relay, there will be a correct coordination. And it will look only a forward fault, not a reverse fault. And this is only an example also about the forward and reverse of the overcurrent relay here as a direction. And the only thing here you see that we are not using only CT, we use also VT to do the polarization. So the principle of operation from what we have just spoke about very fast is that we have a current transformer, and this will give me the information to my relay. And of course, if I have a direction, then I have the voltage transformer. And then what we have a setting in the relay that we have to do the set value. And then the relay will do the calculation internally, and will do everything after doing the connection. And then after processing the calculation, if there is some problem, it will generate an output to do the bit. And if we animate it to just understand it, we have something like this, and we have a feeder, and this feeder will have a CT and VT circuit breaker. Of course, we have the relay and the battery, which is the complete protection schemes. Now, if I have a fault somewhere in the feeder, what's going to happen? My CT and my VT will give to the relay the information. Relay will process that information. If it meets the value, set value, automatically it's going to send an output, and this output will go to the circuit breaker to open and isolate the fault. So it's basically, this is how it's going to work and finish the tripping for you. Now, how to test all those? We have a lot of test equipment to do it, so we can do it manually, semi-manual, or semi-automatic, and then automatic. So I'll talk about two different ways of testing by two different test equipment by Megger. First one is Spherical 900. This is the latest, one of the latest test equipment. We have three-phase test equipment. Everybody knows this Spherical as single phase, but we have it as three-phase. Now, this Spherical can generate, as I say, three-phase current, three-phase voltage, and you can use it for everything, mostly everything. It's basically, if someone knows the Fraser 300, it's page 123 with extra things. Now, and if someone knows about the Spherical, the old Spherical, like 700 series, you will know that you have on plus time, off plus time. So the same thing is applied here. Now, how to test the overcurrent relay using the Spherical? It's very easy. It's just connecting your output of the Spherical to the relay. And then if we want to do it as semi-automatic, as we say, we can do a pickup dropout, and then we can do the timing test. How can we do it? It's very easy. There is no software needed here. So by the knob itself, we can vary the current. We can vary the current so to see the pickup and dropout. How we do that? We just click, and then as before, on plus time, plus, then we'll say hold my reading. After we hold the reading and we have the connection to my trip, the thing is that you don't need to do anything more than this. Just click on the phase where you want to test, and then increase the current. When the hold gone, it will save the first one, which is the pickup, and then go down. It will hold number 2, and then that's it. This is your pickup and dropout. Without knowing anything, you just increase the knob slowly, and then it will hold the first one and second one, and then it will give you the result like this. Your pickup is this value, which is number 1. Your dropout is this value, and your pickup dropout ratio is this value. It's very easy and doesn't need any extra thing. So it's basically, if you know how to operate the equipment, it's going to be something very easy to do. So this is how to do the pickup and dropout to make sure that the set value in the overcurrent is right. Then we have to do a timing test, and this is where we have also from the same page, when we click on plus time, there is an icon in the here right side near to the start button. This is where we will do a pre-fault fault, and we will do a multiple timing test. So it's basically set the first value over there and then start the equipment. And then when you start the equipment, every time you change the value in the current and then press the knob to give the fault. So you just change the value in the current, press the knob and get the fault. After that, you will have a lot of tripping time over here, if you see. And then by clicking the icon here to have it like a curve type, then you can have your timing table like that. So you can export this if you have the software what we call Megger viewer, and you can generate a report with a graph telling you your pickup as we tested in the first stage, and then the dropout plus the timing test, and you can have some report like that. So the report will cover everything by the Megger viewer. Megger viewer is a separate software that you can take the results, and then the software itself will do the job for you. So that is from the Megger viewer, from the Megger side. And then, of course, the Megger is really a very good equipment that can cover and do a lot of testing, not only for overcurrent, it can even do impedance relays. So it's a very good test equipment that can do automatic and very fast, or semi-automatic and very fast testing for you. We have a lot of application guides in our website, so you can go also through our website and browse those application guides and how to test different type of relays, different type of schemes even, because since it is three-phase test equipment, we can use it for so many applications: metering, SCADA, transducer, CT, secondary injection, VT. So a lot of things can be done with this Megger. Now, how can we test? We can test also with the automated test by using the RTMS software. In the end of this session, we will have a live demo with the relay. We'll connect our Fraser directly to the relay, and we'll test from the Fraser on board without using a laptop. We will do with B142 MICOM relay. So we will do a pickup dropout a different way, and then we will do a timing test. And then we'll generate a report and we'll show you how you can save your test plan and repeat the test. So I'm using the latest software here in the explanation published in our website at Megger, which is version 11.29. So how many ways we can do the testing? We have actually a lot of different ways. I will talk about 3 different ways of doing the pickup and the timing. So the first one is from the main page. So from the main page, which is general page, we can do most of the test here. Since it is already a general, so you can do whatever you need. So how can we test over here? It's the same thing, basic thing, that you can just choose the phase you want to do a test. And then, of course, you have to choose a pre-fault fault. If we go a pre-fault and then to fault, means we will do the timing test. If we are in a pre-fault and then by the knob we increase and decrease to do the pickup test, that means we will do the pickup and dropout test. So we have two different things from the main page. We can do the pickup dropout plus the timing test. If you notice here, we select the phase we need, and then there is a highlight in the same phase when we include it for the ramp, so that we can ramp it manually to do the pickup and dropout. And then we choose the contact, where is my start, where is my trip, And when you click on your contact, of course, you have to, you can rename it. So this is, I just renamed in our software, the same thing you can do. So by clicking here, you can do, as I said, the recover dropout, and then by doing default false, you can have the timing test. This is a quick test, but this is not automated. This is manual testing. That's why we have something more advanced to do more automated thing, and that's when you click in our testing tools. So at our testing tools, what do we have? We have a lot of things. But our main thing here, what we will talk about today, is the ramping, where we'll do the pickup and the dropout, and of course the timing. The timing is including also, it can include the instantaneous test and also pickup and dropout. But just to talk about the different two tools, we will talk separately about them. So for the ramping, if you see, it's very easy thing. The only thing you have to understand is that only one variable here will change to do the test for us. If you set it one time right, you don't need to set it second time and third time. And it's very easy by just selecting, of course, if we want to do the pickup and dropout, we have to report all the runs we are going to do. So pickup and dropout means we'll do 2 runs. Our software can do 24 runs, but we'll do now 2 runs. And then the contact, we have to choose that it have to close because we are in run number 1 to do the pickup. And then we'll choose the current and then the phase where we will work on. And then later we will use, we have different, if you see ramping stage. So we have a stair ramp, we have the normal pulse ramp, and then binary search ramp. The difference is that when you have an instantaneous, and then you have to go with a pulse ramp or binary search. If you have only overcurrent without anything else, you can go with the stair ramp. The stair ramp also, you have to use it always for the dropout because this is continuous current. And then, of course, number of ramps, we are in ramp number 1, and the expected current. So if you see that my expected current is 1, and the only thing here we have to understand here that it is start from 80% of 1 ampere. It will go for default if I need to, or I can set it to 0. And then this is my increment, how much, and this is where it goes and wait for the time until it goes 150%. So this is the only test we have to do. I mean, this is the only setting we have to do. After that, when we go to ramp number 2, it will be the same thing, expected current, if you see. So 2 things you have to notice here, that the contact have to open. And of course, we are ramp number 2. And same expected current, but starting point will be from high, which is 120%, it will go to 80%. The first one, if you remember, it was starting from 80 to 120. Now we start from 120 from up to down to 80%. And if we set it right like that, you will just play and then you'll get something like this. So you'll get the pickup and drop out. And then the good thing here is that you can rename it. So whatever is the blue, I just rename it instead of ramp. I just put it pickup drop out. And then I put here the naming, like it's like point number 1, point number 2. I put it also pickup drop out. And then you have a time, you see timestamp about your test and how much duration. Of course, I'm doing simulation, but we will do it now in actual. The other thing is that this error is changeable. So you can put it like 10%, 5%, whatever you like. So this is the blue thing means it's changeable. Now, since we finished the test, it's automatically being saved in our test RAM, which means that we can use it again and again by only changing one value, if you remember, which is the set value. So the set value is very easy to change, which is here for the next relay to do a pickup and drop out. So this is safe. When we save it, it is going to be saved here. So when you click on the magic button, what we call, you will have test being named for you and saved, and you can reuse it. We can reopen the same test. First, we can, of course, this is for the magic button, and this is what we have in the test. This is to view the results, which is in the background. This is to change the value. So if you click over here, you will go inside the test, and instead of 1 ampere, maybe 2 ampere, just click over there and change it to 2 ampere. And then, of course, we have something advanced to link to the setting that we will talk in different subjects. And then we have the other one, which is the timing tool. So the timing tool will do also automatic testing, and then you have to change only, as I said, like only 2 settings or 3 settings to do. So we can include in our timing tool, we can include our pickup, the one we have done with the, we just finished. So we can also keep it here if you don't want to do it from there. And then we can also do instantaneous pickup test. The thing here, we can go up to 20 elements, and we can choose a lot of things to do. Now, for example, I choose here like stage 1 and then stage 1 neutral, stage 2 and stage 3 fire. The thing is that we choose this relays what we need over here, and then if there is a neutral combined, then we don't need to turn off the neutral or do anything. We just choose something called current compensation to cancel always your neutral current. This is very important so that no one will forget his his setting is off, or change the setting and forget, or deactivate. A lot of things is happening in the field. So this is to keep everything as the same, and then when you work, you can work the phase over current and then neutral with the same setup without doing any change. So number of elements, as I said, you have to choose to understand how many we have. And then, of course, this is you can rename them the way you like. So this is first one. We can just come element name and change it the way you like. And then, of course, which phase we will test, like we'll do phase A, B, C, for example, in this case. And then this is very important to do also. You have to choose the relay type or the curve type if it is standard. So you have to click over here and do all the necessary changes. So this is the change. The first change we'll do to do the curve type. The second one is what is the pickup type and what is your time dial or TDM. And then the third one here is to do the pickup and drop out if you want to do the pickup and drop out from here. So if you finish from this is saved again. Of course, when you do a pickup and drop out, you have to put the drop out so that you have the correct ratio. So when you finish over here, and this is the phase compensation, you will have a pickup directly to go to the pickup. So on the pickup, you see that we'll do a 3-phase pickup and phase A, B, C, and then we can do a pickup drop out, and then you'll have the ratio over there and the assessment. So it's very easy. And it's very important to know always that for the pickup, you have to use a contact. For the trip, it's different contact, because pickup is a start contact while the trip is trip contact. So here, I just choose contact number 1 for my pickup. And then, of course, we have so many, I think I told you, so we can do also the timing test here. So from here, you click, you can have the timing test, the neutral pickup, neutral timing, whatever we set in the first page, we have it here. And then when we go to the timing test, of course, we can do the timing test according to the setting we choose over there. So we'll have the curve, and then we have the assessment minimum, maximum, and then we can add points or change those points. And if you have a wrong assessment like what we have here, you will have it always, you will have it wrong. So this is what we have, You can do the assessment right, you can do your automatic testing right. The thing that you have to notice that I have choose here contact number 2, and this contact number 2 is programmed for the trip. So if you do a test plan, it will save also this information, like contact number 1 is start, contact number 2 is trip, and then you can also put it in the procedure or a pop-up window that will guide you what to do. And now when we finish, when we click to the magic button, again, you will have that we have added our new pickup test and timing test of the relay. We can run all of this together because we generate, this is our test plan. And then if we finish, we can have the report directly. Now I will show you a report that we have done here with some relays. So as per this, the customer needs to do some kind of inspection. So we include the inspection and then visual visual inspection, functional check, input, output, release. And then we do something like for the measurement. So we want to do a measurement to make sure that the relay is right. And this is very good because our software can generate different metering value, and then you can write it down. And this is very important to know that your connection is right and everything is right. So you have a proof that your connection is 100% right. And then, of course, the overcurrent test, where you will have all the settings. So the current setting over there, the phase pickup timing, instantaneous, etc. So when you finish this as a template, you can use it and change the setting by yourself or advance by linking it to your whatever setting you are exporting from the relay. There is another thing that we can also take the setting automatically or manually as in FC. And then what you will have something like this, that you will have a very good test format matching your customer needs. And you will have a very detailed, everything is detailed, where your customer doesn't need to do much more than taking the file, upload it to their system or print it, and that's it. So it's very easy, and the same file can be reused by only changing the set values, as I said, manually, and then save. And you can use the same file again and again, and you can give it to your friends. It's very easy to create and very easy to give to others. If you have any question, please go on, or we can go and do the live demo of the same test I explained now in the RTMS.
All right, everybody. Hi, welcome. We have a Freja system here connected with a protection relay B142 there. We will do some overcurrent testing from the main page, then from the ramping page, as Murtada have explained, and then from our timing test. So this is the front page of the Freja 500. We will do a quick pickup and timing test from it. If I just zoom in a little bit. For the timing test, I can for the pickup test, I am using contact number 1, which I configured as a start contact to do the pickup test. So I will be starting with a value less than my pickup, which is 1 ampere. They will start injecting. As you can see here, the contact is not closing, contact number 1, and then I will start increasing the current. Now at this value, the contact has closed. So I consider this my pickup value as a manual method of testing. I can then decrease my current to get my drop-off value. Which is usually 0.95 ampere. So this is my drop-off value. As you can see, my start contact has opened again. This is as for the overcurrent test. For the pickup test, if I stop, then I want to do timing test. I should inject values above my pickup value. So I will inject 1.5, for example. And they will click start contact, but I'm going to use contact 2. Contact 2 use as a trip. Now my contact 2 will be used as a trip contact for me. I will click start. And I got a trip time now equal to 3.47. It depends on your setting for the timing and also the curve that you have selected. For example, if I put a higher current, 2 ampere, I will get even a faster trip time, which has become now 2 seconds. Now this is for using of the main page. I can do it for phase 1 or phase 2 or phase 3 or phase to phase or even 3 phase altogether. Ramping for pickup and also time. Now, as for the ramping test, as my colleague Murtada explained, okay, click here and they get the ramping function here and the timing function here. We will start with the ramping function. I will click on it. As Murtada, my colleague, have explained, first I will select my contact, which is contact number 1, which I have connected start contact to it. I will be ramping current I1, phase A only. My expected value is 1 ampere. I will be starting 85% up to 120%. If I have a different value, I just click on the expected value and I can change it to whatever I need. This is for the pickup. As for the drop off, I will be having a second ramp, a second ramp, and this second ramp is 0.95%, but I will be starting from 100%, 110% of it, going down to 85%. So I will be going down in my ramp. And my contact will be the opposite. I'm waiting it to be closed, not to be waiting it to be open, not to be closed, as this is a ramping or drop off test. So I will click start the test, still start with the pickup by increasing the current automatically, and then decrease it for the drop off. Can add this to report. It will be added for me here, as Murtada has explained in the report. I can click on the name and change the name to call it pick up drop out test. I can change the first ramp name to be pick up and the second ramp drop out, as I like. And also my result, I can give an assessment allowable error. So 5%, for example, and I can give, for example, here 5%. If this value, the error value, is more than the allowable error, it will give me direct failure. So if I, for example, put this one 0.5, it will give me an X failure automatically. This is my error. Now, since I did the pickup and drop off test, I can see them in my test screen here. I can click here to see the report, or can I click here to go back to the test screen to change any test value if I want. Also, if I want to repeat the value, this one, I can just click here to play, or the double click to play all the tests that are included in my test template. The second thing I want to do is using the timing tool. Here, the timing tool. Click on it. Since I already have done the pickup test, I will not include it in my test, and I don't have any instantaneous stage, so I will not include it as well. The tolerance is usually it's pre-defaulted to a very good value, so in case you don't need to change it, don't change anything here. So I click OK. I will have only one stage, which is a phase element. I have phase A, B, and C. And since I am connecting to my neutral, I will be using phase compensation option. As for my curve that I'm using, we have a huge library. I'm using an IEC curve. Click on it. And I select my IEC library curves. And I am using the type standard inverse, or called IEC curve A, in my relay. Click on it. And then my pickup value is 1 ampere. And my time dial is 0.2. And that will be all for my testing settings, or my overcurrent setting. I'll click OK. It will take me to the test screen, where I have here a curve that I can select value from this table in it. The first thing I need to do is select my contact, which is contact number 2, the trip, not the start contact, since this is a trip time test, and I'm waiting it to be closed. So I can have different values here at 2 times of my nominal, at 3 times, and at 5 times. And each one will calculate directly how much minimum and maximum time allowable, depends on the setting that I have selected. So I click play. I can select any phase only or all phases to play the test. So this is for phase A. You You can see here the relay is tripping. So I got all my results correctly. If I want to see them in my report, I will just go to view report, and I can see all my report here, the timing test that I have done first, or the pickup test that I have done, and also the timing test below. And if you want to see the template or the repeat the test again, I can just click on this magic button again, and I have my pickup dropout test and also my overcurrent test available for me. So I can just double click all, and this for this relay, and to run all the tests that I have done again and again. If I need to change anything in this test, I just click on the test I need, and I click the test screen, and here I can change any value to repeat the test for another relay with different settings. That will be all for the demo section of the Frege. If you have any questions, please feel free to ask them so we can answer them for you right now.
Ali, can you repeat the whole test from the test plan to do the pickup dropout and then
Yes.
to do the dynamic test one time, please?
Sure.
What you see here is that the test plan we have created now for pickup and dropout, and then the timing test, it will be repeated by itself. So the only thing you have to do is change the setting your side, which is manually, as Ali explained, and we have something advanced to read from the relay or read from a setting file, but that needs another actually, let's say, webinar or some kind of training, because it needs a little bit of practice to understand it. But this will give you an idea how we can add more and more actually tests and do the test plan. And then this automated test plan can be used by anyone. So if you want this and save it, after this, save it, please. If you need it, we can send it to you also at the end of the presentation.
Okay, some questions.
I can see the questions, Ali. So the new questions
you,
is...
you want to answer the question, but...
Yes, yes.
Yeah.
Is all tests which we can do with the Frege 1 software, we can do with RTMS software?
We already answered this question. So
okay.
It's the
the next question is... that's more of a suggestion. I suggest change the icon of the step down from the 110% down to 95%. What is shown is the ramp going up. I suggest is the ramp should be going down. Thank you for this suggestion. We will consider it and send it to our development teams. Another question, can I change the header and the footer of the report? That's a very good question. Yes?
There is a question before I suggest as well, if you can answer it after.
Okay, guys, so if you have any questions, you can type in now in the chat box, and we'll answer it for you. So maybe we can give 1 minute for them to type in their questions if they have. So yeah, guys, for those who are leaving, please don't forget to fill up the survey form, and that will really help us in improving our future webinars. And yeah, we still have a lot of future webinars, so please stay tuned. You can check the website for the schedules and for the topics. It is all written there and stated there, the next webinars that we will have. So yeah, your questions are welcome. So if you have questions in the future, you can also send us an email and we'll try to answer you back through email as well. I don't see some questions here, Zoom. Do you see any question? Zoom?
Yeah, I think there is no question there now.
Okay, so I guess no questions for this webinar. So I guess let's conclude this webinar. All right, guys. So again, if you have any questions, just send us an email. Okay. So for those who attended, thank you so much for attending this webinar and hope to see you again next time. Have a good day and please stay safe. Thank you, Ella. Thanks, Sumaidi. And thanks,
Thank you,
James.
Michael. Everyone. Yeah, bye-bye.
Goodbye.
Thank you, Michael. Thanks, Maydi. Thank you, everyone. Bye-bye.